Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have geometry. We have unit 4, lesson 3. The lesson is called the converse of the isosceles triangle. Last time we have studied the meaning of the isosceles triangle, and we have studied the relation between the sides or the legs of this triangle and the base angles. Okay, and we studied the equilateral triangle. Today, inshallah, we are going to introduce the converse of the theorems. Okay, let's start the lesson. Let we have a triangle like this. In this case, if we have two angles are equal in this case, then this triangle is called an isosceles triangle because the two sides opposite to these two angles are equal like this. Again, if we have a triangle in which two angles are equal, then the two sides opposite to these two angles are equal. In that case, the triangle is an isosceles triangle, and the side that included the two equal angles called the base, and the two equal sides in that case called the legs of this triangle, like this. If two angles of a triangle are congruent, then the two sides opposite to these two angles are congruent, and the triangle in that case is an isosceles, and this one called the converse of the isosceles triangle or isosceles theorem. The other converse, if we have a triangle like this in which three angles are equal in measure, then this triangle, which included three equal angles, is an equilateral triangle like this. Okay, and we can say that if the angles of triangle are congruent means equal in measure, then the triangle is an equilateral triangle. Another case, let we have a triangle like this, and we have in the given that two sides are equal. That means if we have angle of measure 60, that means what? When we have isosceles triangle, as we studied in the last lesson, okay, if we have here 60 degree, then already we have here 60 degree. And to find the third angle, we are going to make 180 minus open brackets 60 plus 60, it equals 60 degrees. We see that this triangle is an equilateral triangle. Again, if we have in the first given that we have isosceles triangle and one of its angles equals 60, that means the triangle is an equilateral. Okay, then we can say that in an isosceles triangle, if any angle has measure 60, then the triangle is an equilateral triangle. Now we have, this is the three rules of the converse of the triangle. Let's solve problems about the concept of the converse. Example 1 with us. xy equal xz in this figure, and L belongs to yz, as we see. M, measure of angle XYL equal 120 degrees. Prove that this triangle is an equilateral triangle. We just need one angle of measure 60 degree inside the triangle to prove that this triangle is an equilateral triangle. Okay, it's very easy. Here we have straight angle. Okay, then this straight angle whose measure 180, then 180 minus 120 equal 60 degree, as we see. Then once we have isosceles triangle with 60 degree, that means this triangle is an equilateral triangle. Okay, first, since I will write this given in the beginning to prove that this one is a straight angle. Since L belongs to Z, Y, therefore measure of angle X, Y, Z equal 180 minus 120 degrees equal 60 degrees. Okay. Then in triangle XYZ, since XY equal XZ and measure of angle XYZ equal 60, therefore the triangle is an equilateral triangle. Or you can, by another way, you can find, since we have an isosceles triangle, okay, and this angle equals 60, of course this angle equal 60 degrees because the base angles are equal in measure. And to find the third angle, I'm going to write 180 minus 60 plus 60 equals 60 degrees. But I don't need to write all these steps because I have a rule I studied in the last rules that if we have isosceles included 60-degree angle, then this isosceles triangle is an equilateral triangle. And this is the rule that I used in this example. Okay, another example. In the opposite figure, as we see here, AD parallel to BC, measure of angle ADB equals 40 and the measure of angle BDC equals 100. Prove that the triangle here is isosceles, triangle DBC. Okay, first, here we have, okay, as we see here, we have AD parallel to BC. Okay, if we join them by this transversal, we get Z letter as we see. Okay, that means we are going to reflect 40 from here to here, then this angle equals 40 degrees alternate angles. Okay, now we have triangle in which we have angle of measure 100 and the other angle equal 40. Now I can find the third angle, 180 minus 100 plus 40, which is equal 40 degrees. Then this triangle is an isosceles triangle and we can say that DB equal to DC. Okay, now to write the proof. First, since AD parallel to BC, therefore measure of angle ADB equal to measure of angle DBC, and this one called alternate angles. Okay, in triangle DBC, since the sum equals 180 degrees, here I mean the sum of the interior angles, therefore measure of angle C equals 180 minus open brackets 100 plus 40 degrees equals 40 degrees. Therefore, measure of angle DBC equal to measure of angle DCB equals 40 degrees. Therefore, the triangle is an isosceles triangle. Okay. The next one, in the opposite figure, B belongs to XY. As we see, this one is a straight line. XY is parallel to AC. As we see, we have two parallel lines. Measure of angle ABX equal 62. Measure of angle C equal 56. Now we need to prove that AC equal to BC. Again, AC equal to BC. Okay. Now we have here also two parallel lines. As we see here, XB parallel to AC like this. If we connect them by this transversal, we get Z shape. Okay, that means this angle A equals 62 alternate with this angle. Okay, now to find the third angle with us, we are going to make 180 minus 62 plus 56 equal 62. That means AC equal to BC, and this triangle is called isosceles triangle. Now to write the proof. Since AC parallel to XB and therefore measure of angle A equal to measure of angle XBA equal 62 alternate. Okay, in triangle ABC, since the sum of interior angles equal 180 degrees, therefore measure of angle ABC equals 180 minus open brackets 56 plus 62 degrees equal 62. Therefore, measure of angle A equal to measure of angle CBA. Therefore, AC equal to BC. Next, here we have AC intersect BD equal M and MB equal MC and AD parallel to BC. Prove that MA equal to MD. First, we have here, since MB and MC are equal, therefore angle M, angle B equal to angle C, because this triangle is an isosceles triangle. Okay, and since BC and AD are parallel, therefore angle B equal to angle D alternate, angle C equal to angle A alternate. And since angle B and C are equal, therefore angle A and D are equal, therefore MA equal to MD. Now I'm going to write the proof. Since in triangle MBC, since MB equal to MC, therefore measure of angle B equal to measure of angle C, and this is relation number 1. Since AD parallel to BC, therefore measure of angle A equal to measure of angle C, and measure of angle B equal to measure of angle D, and this is alternate angles. Okay, therefore measure of angle A equal to measure of angle D, therefore MA equal to MD. Next, example 5 here in the opposite figure. ABC is a triangle in which BD bisects angle B, ED parallel to BC. Okay, prove that triangle EDB is an isosceles triangle. First, since DE parallel to BC and the transversal DB connect between them, here we have Z shape, therefore angle DCB equal to angle EDB. Okay, since angle DBC equal to angle DBE, therefore angle EBD equal to angle EDB, therefore this triangle is an isosceles triangle. Again, angle CBD equal to angle EBD, because DB bisect angle B, and angle EDB equal to angle CBD, alternate angles, therefore angle D and the angle B are equal, therefore the triangle is isosceles triangle. Okay, the proof: since BD bisects angle B, therefore measure of angle EBD equal to measure of angle CBD, and this is number 1. And since ED parallel to BC, therefore measure of angle EDB equal to measure of angle CBD, and this is number 2. Okay, from 1 and 2, therefore measure of angle EDB equal to measure of angle EBD, therefore triangle EBD is an isosceles triangle. Next one, example 6. Here we have ABC is an equilateral triangle, as we see here. F belongs to AC, okay, and D belong to BC. That means this AF is a straight angle and CD is a straight angle. Okay, measure of angle DFC equal 30. Prove that triangle DCF is an isosceles triangle. Okay, here we have equilateral triangle, then each angle inside equals 60. Okay, and AF straight angle, therefore measure of angle DCF equals 180 minus 60, 120 degrees. Finally, to find the angle D, 180 minus 120 plus 30 equals 30 degrees. Therefore, angle D equal to angle F. Therefore, the triangle is an isosceles triangle. Okay, now I'm going to write the proof. Since triangle ABC is an equilateral triangle, therefore each angle equal 60 degrees. Okay, since F belongs to AC, that means this one is a straight angle. F belongs to AC ray. Therefore, measure of angle DCF equals 180 minus 60 equals 120 20 degrees. In triangle FCD, since the sum equals 180 degrees, here I mean the sum of the interior angles, therefore measure of angle D equals 180 minus open brackets 120 plus 30 degrees equals 30 degrees. Therefore, measure of angle D equal to measure of angle F equal 30 degrees. Therefore, the triangle is isosceles triangle. And this is the end of the lesson. I hope it was helpful for you. See you in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.